Hello everyone, in this video I will solve this problem from advanced mathematics. So the problem says a sequence is obtained from the positive integer sequence by removing perfect squares and perfect cubes. What is the 2019 term of this sequence if the number in the sequence are in the ascending order? And the options are 2070, 2071, 2072, 2073 or 2074. So I will try to solve this problem in a very easy way. So let me start. I will try to explain all the concept to solve the problem. So the first thing you should know, or you guys should always remember that whenever we have a number, for example, if I want to know how many square terms are less than 10, how many perfect squares which comes before 10. So let me first write these numbers from 1 to 10. 1, 2, then 3, then 4, sorry, 4, 5, 6, 7, 8, 9 and 10. Okay, so before 10 we have how many perfect squares are there. So we know there are two perfect square here. Now the number 1 is number 1, the first is number 1, and the second is 4. Actually there are 3, 4, and the third one is 9. So there are 9, there are 3 perfect square before 10. So if we have very finite number of digits, or we can say we have very few digits, then it's very easier to see. But how could we tell how many perfect square before 2019? So there will be so many perfect squares. So how can we do it? There is an easy way to tell that. We just take the square root of 2019. This will give us the number of perfect square before 2019, and if we take the square root of 2019 using calculator, we will get 44.9, and we should always round it to the whole number. So 44.9 is approximately equal to 45. So we could say there would be 45 perfect square before 2019. Similarly, if we do under root 10, we get, just to make you clear, this should be around 3. So if we take under root 10, square root of 10, we get 3.16. And we know this is approximately equals to 3. So and we know that there are 3 perfect square before 10. So by this logic we have 45 perfect squares before 2019. Okay, is that clear to you? Now moving further, we also know that how if we ask you how many perfect cube before 10. So by similarly we can just take cube root of 10, and it will give us number of perfect cube before the number 10, or that comes before number 10. Okay, if we take perfect cube of 10, we would get 2.15, and which is approximately equal to 2. And we know that there are two perfect cube before 10, that is 1 and 9, sorry 8, 1 and 8. These two are the perfect cube before number 10. So this is the first thing you all should know in order to solve this question. Now what is the second thing you should know to solve this question, so that you won't get confused? Okay, so let me tell you. Okay, so if I give you these 14 natural numbers and I ask you what is the fifth number, you would easily say that it is 5. Okay, let me mark it here. This is 5. The 5 is our fifth digit. This 5 is our fifth digit. But now if I ask you what is the fifth digit after deleting all the perfect squares, so if I delete all the perfect squares here, so I know this 4 is a perfect square, 9 is a perfect square, 1 is a perfect square. So these three are the perfect square. Now if I ask you what is the fifth digit, then you will count 1 2 3 4 and 5. So the fifth digit is 1 2 3 4 5. The fifth digit would be 7. So if you notice that what I did, the previous fifth digit was 5, and what sorry, 5, and if I delete the perfect square before it, the fifth digit would be 7. 1 4, then 1 2 3 4 5. Okay, so we always have to add some number in order to get the digit we obtain after deleting perfect square. Some students become confused here and ask me uh, why shouldn't we subtract the number. So this is the logic. We add those digits because when we remove the perfect squares from the given sequence of natural numbers, the sequence will automatically move forward all the digits, because now the sequence will be started from 2, not the 1. And if we count five digits from 2, then we will reach to 7, because 4 is also removed. Another thing you should notice that how many perfect square were before 5. So we see that there were 2 perfect square before 5, and we added 2 here, so we would get the number 7. So the logic is here to get all the digits after deleting the perfect square is just to find the number of perfect square before that particular digit and subtract the number of perfect square from that digit. For example, here our desired number was 5. We need to find the fifth digit of the sequence on which the perfect squares was removed. So we will just count how many perfect squares was before in the original set and delete and add those number of perfect square to this 5. So we will get 7 here. Okay, so also if I if the question was not this, the question was like to find the fifth digit after removing all the perfect squares and perfect cube. So how would we do? So we would take cube of 3 as well. So to find number of perfect cube before 5, we know that there is only one perfect cube before 5, which is 1. So this is 1 perfect cube before 5 and 2 perfect square before 5. So we can also write it as now. Now I will formally write solve it. So number of perfect cube less than equals to 5 is 2. Sorry, this is 1. And number of perfect square are 2. Okay, so we would just add these number to are 5. So there are 5 plus 1 plus 2. So our fifth digit would be 8. So let me check it. So if I have 5 and I remove 1 and 2, 1 and 4, and then what would be our, because the only perfect cube is this one and no other is, so what would be our 8 digit, it would be 1 2 3 4 5. The fifth digit here is 7, but we got the number 8. Why this happened? This has happened because we counted 1 2 times here. We use this as perfect cube and perfect square as, so we need to subtract that one. So I would subtract that one. This would give us 7. Okay, so the formula here to solve this type of problem is that we would first find the number of perfect cube, then we would find the perfect number of perfect square, and then we will delete the intersection of both, because there could be some number which is a perfect square and perfect cube as well. For example 1 is a perfect square and perfect cube, 8 is a perfect square and perfect cube, 64 is a perfect square perfect cube, and there are lots of more. Okay, if in our sequence we have to delete these kind of numbers. Now I will solve the problem now, because I wanted to clear the concepts from the simplest example. Now I will move to this 2019 term. Now in order to solve this problem, we need only these three things. The first is the number of perfect square less than equals to 2019, the number of perfect cube less than equals to 2019, and the intersection of both perfect square and perfect cube less than equals to 2019. So square root of 2019 is, and we have to round it to perfect integer. So 2019 square root of 2019 is almost 45, and cube root of 2019 is, so let me just write here, you can verify it from calculator. So this is 45, and perfect cubes is 13. You can it would be 12.63, but if you round 12.6 to integer, it would become 13. So you would write 13, not 12 here. And and let me in order to make you things easy for you, just remember this: the first 4 perfect square which are perfect cube as well are 1, 64, 729, and 4096. These are the first 4 perfect square which are also perfect cube. So 4096 is greater than 2019, so there are 3 perfect square, which is also perfect cube. So the answer here is what happened here. Okay, so the answer here is 3. Now what we do, we will just add these two and subtract the intersection part. So the answer here is 2019 plus 45 plus 13 minus 3, and this would give us 2074. So option E is our correct answer. Hope this video is very clear to you. If you have any problem, you can ask me in comment section. Even if you find this video difficult, I can make another video to on the same question to make things more clearer to you. Please do comment below. Thank you so much.